Hi, so this is going to be a short video that's going to describe Newton's laws to you. I suspect if you've taken physics before, you've probably uh, you've dealt with these before, so this will be a pretty quick overview, but hopefully kind of cover all the basics of the theory, and then after this we'll move on to applying Newton's laws to solve problems. So before we get into Newton's three laws, I would mention that these are really kind of the foundation, the meat and potatoes, you might think, of mechanics in physics. And this is really critical stuff for engineers to know, to understand how it's underneath entire engineering areas like statics. And this is also kind of a cool topic. You might think like, well, this is just kind of the basics, but this is really the context where these notions that we have about things like force and mass, weight, um, we can discover that they actually have specific definitions in physics, and we can give some rigor to these ideas that we have kind of notions about in our everyday lives, which is kind of cool. So, Newton's first law: every object continues in its state of rest or of uniform velocity in a straight line as long as no net force acts on it. So this is the definition as described in your textbook. Um, what does this mean? Well, sometimes we call this the law of inertia. So you can think of inertia as the property of an object which resists its changing from rest to motion, or changing if it's moving from changing direction. And the measure of that property, inertia, is the object's mass. And in SI units, the units that we use, the unit for mass is the kilogram. So to repeat this definition, basically every object is going to continue what it's doing, be that rest or uniform velocity in a straight line, as long as no net force acts on it. So it can be either at rest or moving in a straight line. Changing direction would mean that you're accelerating, and so that cannot happen unless there is a net force. So that's Newton's first law, the law of inertia. Newton's second law. The acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to the object's mass. The direction of the acceleration is in the direction of the net force acting on the object. So this describes how we relate acceleration to force. The acceleration of an object, notice it's a vector, as is force, is equal to the net force. So we use this sigma, short for sum, is to tell us that we have to add up the forces on the object. And the net force is proportional to the object, or I should say the acceleration is proportional to the net force, and that proportionality is the mass. So, and that was our measure of inertia. So the larger the mass, the smaller the acceleration is going to be for a given force. The smaller the mass, the larger the acceleration would be for a given force on an object, a given net force. A lot of times we see this written as the net force equals ma. And if you've dealt with this before, we often give this shorthand as just F equals ma. Newton's second law. And you can think of force as basically the thing capable of accelerating an object. And in honor of Isaac Newton, we give the unit of force is the Newton. And you can see that a Newton is equal to a unit of mass times the unit of acceleration, meters per second squared. So this has units of kilograms times meters per second squared. Okay. And just to emphasize, net force, that word net means total. And that's why we'll often use a sigma, a summation, to indicate that we need to add up and find the total force. And this really becomes, you'll see this as you practice solving problems. A big part of solving problems with Newton's second law involves adding up the forces that are acting on the object and finding the net force, the total force. So remember, this connects directly to what we did with projectile motion, where we broke forces into components. So you're going to have to do practice that same skill when using Newton's second law in solving problems. Find the components of force that are acting on an object, add them up, and find the net force. If you know the net force, you can figure out how the object is going to accelerate if you know its mass. Newton's third law. Whenever one object exerts a force on a second object, the second exerts an equal force in the opposite direction on the first. So this you can think of like, let me try and draw a picture. If I was to apply a force to this box, and then this box, let's call this one A, this one B, was to apply a force on here, this second box would apply a force in the equal but opposite direction to the first. Let's see, what else did we want to mention about this? An excellent example of this, which is what we're going to talk about next, is weight. So if you have an object that's resting on a surface, it exerts a force on that surface, the object's weight, which is its mass times gravity, and that surface will exert a force back on the object in the equal in size but opposite in direction. And we call that the normal force. And one detail that we'll clarify here shortly, the normal force doesn't necessarily equal the weight, but you can think of it as the force that is perpendicular to the surface. So, and depending on the circumstances, for example, if you were pulling up on this object, it wouldn't equal the same as the weight, but it would still be the force that is necessary to keep that object from falling down through the surface. So we will spend some time being more precise about these ideas, but this weight and normal force is a good example to think about when we're talking about Newton's third law. And kind of the strategy that we're going to apply to solve problems, so just foreshadowing here a little bit, you're going to draw, I'm going to try and model and emphasize to you that it's really useful to draw yourself a picture. We're working with vectors. Drawing a picture can help us keep track of the directions that the various forces are pointed. And in this environment, we call these pictures free body diagrams. So you might have some object, and you would figure out all the forces that are acting on this object and record them in this picture, the free body diagram. And then the next step, we would find the forces in x and y and add them up. If the object is accelerating, we would find the acceleration via Newton's second law. And if the object is not accelerating, you can use your force equations in x and y to solve for unknown quantities. So, for example, maybe you know the force in x and it's related to the force in y. And if you know that one, then you may be able to find the other. So this oftentimes amounts to us using algebra to solve for unknown quantities based on equations that we derived from Newton's second law and finding the net force. So that's where we're headed. We'll try and apply these skills on some example problems, so stay tuned.